Well, good afternoon, everybody. Thanks, my good friend Pierre-André Adisseu, for the invitation. It is absolutely outstanding to be here with you, talking about a subject that I really like very much. And before starting, that will be my agenda, I would like to say two statements that are very important to understand what I'll be saying. It's important to say that the birds eat because the birds drink. And if they drink, they eat, and if they eat, they grow. The correlation in between these three aspects is absolutely close to one. So if there is no water consumption, there are no feed consumption, and there are no weight gain. Remember that the birds do not have too much saliva. So if the water is not there, the intake is very low. So based upon that, as introduction, I think I got this beautiful chart that explains everything related to litter wetness. It's a kind of a complex situation between different aspects, but I would like to stress that the main point when you talk about wet litter, we are talking about environment. There is nothing to do to solve wet litter without taking care of the environment. We can mitigate, and I'll show some of the way that we can mitigate, but we cannot solve. Drinking system can be one of them. That if you regulate in the wrong way a drinking system, you can get wet litter. Remember, there are many ways to offer water to the chicken, and sometimes we treat them as the same all over, and that's not the case. It's important to consider what wet litter is. Anytime that we have more than 25% of water in the litter, we should say in the litter, we are talking about wet litter. And the wet litter is a relation in between what the animal consumes and what the animal transfers to the environment. And I'll be talking about that later. And when we get wet litter, we get lots of problems. We are talking a lot now these days about animal welfare. And for sure, foot pad dermatitis is the most complex one, but we have also blisters, ascites, environmental ammonia, environmental CO2, flies, prisons, bad odor, and then we get to the business part. We have a reduction in broiler performance, we reduce the feed and breast quality offers, and by the end of the day, we lose some part of the animal at the slaughter plant. So it's quite complex as a consequence, and we need to be looking at that very carefully. When we go to the environment, it's very important to say that a big challenge in the chicken house is to reduce the humidity. Whenever you reduce the humidity, you get together a reduction in CO2 and ammonia. You can continue having high temperature, but you cannot have humidity. That's the reason that some people say, well, what's different to talk about that in Brazil than in Asia and in Russia? No, it's the same thing. You cannot handle high humidity inside of the chicken house. And when we cannot handle that, that's the consequence. And don't expect from anyone else besides the chicken house to fix this with something else besides environmental control. And there is a list of very important things to be done. Ceiling, double curtain, external lateral protections, fans, birds per feeder, and drinkers adjustment, up and down, types and dips of bedding, birds density, downtime, solar position, and diversity of panel controls. So to maintain all these chicken houses control, you need to be very close to all of the things that I put together. In the past, the conventional houses that are all over the world yet, so it's not something that is uncommon, look to be easier. But when we got to this kind of giant, complex chicken houses that I like to compare as a Ferrari, at this case, the most important thing is not the chicken house, is how to manage the chicken house, how to manage this machine. And we need to train people. Without trained people, zero chance. There are hundreds and thousands of chicken houses in the world with different systems, different size, different ceilings, and we want to put all of them in the same box? and that's it. And that's not the case. Training the people is the #1 challenge for anything related to chicken litter. And when we go to water, that was the main issue, and it is the main issue of this discussion. You see that the birds, and sometimes my earlier speakers told many things related to that. Remember that from 1985 to 2009, the animal increased the water consumption in 70%. It makes sense, because they are growing fast, they drink, they eat more. But there are some houses still that we visit when we visit, and I do that very frequently, that still have equipments that were bought here. How you make the birds to drink here if the system do not allow to give that? And that's the question. And that's the question. And as I said before, this is a total water consumption of the bird during its life. Everything that is blue is water that will be putting into the house. So out of 100% of water consumption, 80% of that water needs to be transferred to the house. In transferring to the house, you increase the humidity. And if you don't have a nice system to take that humidity out, you have wet litter. So that is the main issue. And another very important issue that so far we didn't touch on that, and I think it's very important to say, increased consumption of cool water is crucial to survival, especially in a heat-stress broiler system. We talked about water, but we didn't say anything about the temperature of the water. This is a work from Dr. Watkins that she showed that even a very young bird's first day of life, with 3 different temperatures of the water, the birds that started with the same weight, at 7 days they had already 20 grams less, and 40 grams less. Just having a hot water at the reception of the birds, you start destroying the digestive tract, as I will show in the next pictures. So you can cool or make the water better for the chickens in a very simple system, just using bottles with water and freeze it. You can have a refrigerator, you can have ice, you can have this milk cooling system, or you can go to a more sophisticated water. There is no chance to produce chickens with a good water, the best water, human source water, if the water is hot. And when the water is not available, that's what happened. This is the velocity of the chickens with 12 hours of life. Beautiful. If this villi stays 24 hours post-hatch with no food and no water, you have a plenty results of extrusion. So most of the villi would be destroyed, and the recuperation of this villi takes from 4 to 6 days to happen. So if you have a situation that you do not have water and you have feed, bad mucosa. If you have water but you don't have feed, the same situation. But if you have water and feed, you get a very nice microvilli. So you can destroy the situation of the bird in the first 24 hours. And here we're not talking about excess of water. We are talking about drinking water. And I'll show you in this picture. This is one of the works that I had with one of my students late when I was at university. So we made the water restriction of 10, 20, 30, and 40%. That was the size of the villi at the first day. Look, when I have 10 to 40% water reduction, we reduce the surface area for absorption in 20%. And that was not recuperated during the life. And one of the consequences, then later, we decided to say, let's go further. It's another of my ex-student, Dr. Kura. We had a no restriction, yes restriction, 20%. Look the feed intake, reduction, close to 20%. Body weight reduction, close to 20%. Weight gain, the same way, here more, almost 40%. Feed conversion rate, the same thing, because the water consumption was reduced. and 20%. So anytime, and the funny thing at the farms, that equipment that measures water consumption in many houses do not work. People do not read. People do not calculate. And that is the most important thing to see if the birds are eating. When the birds do not drink water and don't grow well in the first week, we have atrophy of the pancreas. And that happens in the first week. Everything that happens afterwards will maintain this uneven condition in between duodenum and pancreas. And we know the importance of pancreas for digestion and absorption. So anytime that we in some way do not allow the birds to drink what they should drink in the first week, the consequences in terms of digestion and absorption will take all the life long. And what about nutrition? Well, nutrition, there are lots of aspects that we can mitigate the wet litter. Excess of protein, excess of mineral and sodium that was very well presented before, the ratio between calcium and phosphorus, excess of specific types of fiber, fat rancidity, mycotoxins, and the non-use of synthetic amino acids or non-use of enzymes. All of those things can favor the presence of wet litter. And I will be touching some of them that I think is important. Anytime that we have increment of digestive viscosity, and remember, when the extrusion comes to the microvilli, the first reaction of the bird is to produce mucosa to protect that area. And every time that we increase the viscosity of this region, we will have dysbacteriosis, fermentation of proteins, and increased digestion to blood osmolarity. That is the most important condition to reduce absorption. And also, you increase the excretion of the water from the kidney. So you disorganize this relationship in water absorption with the nutrients, and you disorganize also the excretion of the water. And you see these pictures all over. It's very common, you know. That happens from 7 to 14 days. It's very common. You get inside of a chicken house and you see this kind of situation. It will be soybean quality in terms of antitrypsin, soybean particle size, smaller particle size, more digestive tract problem, fat quality, so you are in a rancidity situation. And remember that antitrypsins, they also inhibit not just the protein. The antitrypsin inhibits the co-lipase to be transformed in lipase. So this symptom of steatorrhea is very much related to that. In excess of non-starch polysaccharides. And you get this situation. That's what we expect of a normal velocities, and that you get when we have some of those things. So how you can get absorptions here with this kind of microvelocity? So you can destroy the performance and evenness of the chickens at the chicken house based upon a mistake made at the beginning. And when we reduce the protein in the diet, this is one work done in our group in Holland, 1.5% less protein reduces 15% nitrogen excretion. So we are talking about sustainability. So that's very important to be recognized. And this is a very important paper that has 20 years, but make the sense. The authors went from 100% recommendation of Ross at that time, and 90% of that, 80%, and 120. Let's go just to look this over here. This is the water consumption all the way through, 240.6, okay, during this period. Less protein and nutrients, but in this case proteins, less water consumption, more protein, more water consumption. So we have a very important thing. And with the synthetic amino acid, you know, coming up with a normal price or competitive price, we can play with less protein. But I want to bring a very interesting point to you. Most of places in the world work with post-weighting grinding. So you weight corn and you weight soybean, put them together and grind. What you have, when you sieve that diet, you see, depending upon the size of the sieve, different crude protein in the diet. So if the chicken gets to the fine of the diet in the feeder, he probably will be eating 14%. And he is one of the strongest, dominant, he'll eat more protein. And now you know protein relates to water consumption. So you can see birds in the same place eating quantities of water according what they are eating. So if there is a mistake in chicken, is to make post-weighting grinding. It's cheaper, energy wise, but not for the animal. So it's very important to consider and reconsider. So the birds are eating the same diet, but the diets are not the same. Okay, when Brazil was important, and we export a lot of chickens for Europe, and when you people in Europe start to taking out the animal feed to the diets, we got to a problem in Brazil. We didn't know how to make diets without animal protein. And that was one of the first papers that we had published at that time. And what we looked, water consumption with the animal diet and with veg diet. You look at the amount of water. Excreta humidity increased. So when that situation came to Brazil it was a mess. Because we believe it, that everything should be fixed by the diet. But at the same time, by coincidence, the amount of new chicken houses, environmental control houses came together. So it was two good things to make a mess, and that was the situation at that time. But I would like to discuss about protein from another perspective. Last year, when the corn and soybean increased the price, some of the clients came and asked us what we can do to reduce the cost of the diets. And we start formulating diets with 19% and 18% crude protein diet for the growing phase. When we look at this from the amount of CO2 equivalent produced per kilogram of feed, just reducing 1% of the protein, we reduced in 7% the amount of CO2. So that's great, because that is also forcing us to reduce the protein regarding sustainability. And another very important subject that we brought together at that time is, you know as nutritionists in this audience, that some of us still formulates with half standard deviation, what I call neck protection. A little bit more, why not? When we got two clients, example 1 and example B, and we took out the half standard deviation, assuming that the client has the best analysis to be almost real-time formulation. In this client was around $6 per ton less expensive taking the half standard. And in this client, $13 per ton of feed, in this case, no, in broiler production, taking half a standard deviation. So the message is here is tables are good as a reference. The importance to have low protein, the low mass with the water, is to formulate in the real time. And here's our example. If you can see here, there is no noise. Good luck for you guys, because the noise is not that beautiful. This is a system that we are implementing in different situations in the world, where we have a near infrared, either fixed in here, or a near infrared that is over here moving in this way. So you read the analysis, make the analysis right away, and the next batch will have a new formulation based upon 0 standard deviation and with the ingredients that are coming to the formulation. That will be, I would say, and it is already in different places in the world, as one must for real-time feed formulation. Another important thing to protein to be in this context is to be leaving the least cost formulation to nonlinear feed formulation. Because when we talk about least cost formulation, we do not think about the chicken house. We do not think about the environment. We do not think about how we are producing the chicken. Today we can use nonlinear feed formulation that you can put feed conversion, mortality, animal density, broiler slaughter. How many broilers your company slaughter? Is different than mine. How I can have the same diet? To get the production cost, then I have the production cost. I don't have anymore the least cost feed formulation. I have the reduction in least cost of the kilo of chicken at the slaughter place. If you put some downtimes, farm management, chicken cost, and others, you go to total margin. So you can have a worse feed conversion with a better margin. Why not? And that happens a lot, especially in this momentum where the ingredients are very expensive. This is another thing that bothers me a little bit. You know, many places in the world are still formulating with 2 diets for broilers, believe it or not, 2 diets. I put an example number 3. When I have 3 diets, this is one period. Let's assume that that is from 1 to 21 days. Half of the time, I have lack of nutrients for the animal. And half of the time, I have more nutrients than the animal needs. So how the metabolism works over here with lack of nutrients, and how the metabolism works with more nutrients than needed. If we take just over here, this is higher protein level than the animal needs for half of the period. So we need to think about more phases. Because when you have more phases, the lack and the supply is smaller. So you have less of this changing in the metabolism that the animal needs to do in a very specific and small amount of time. And that's a very interesting situation. That's an experiment that was made by Hochschild and others. He worked with 4 phases and multiple phases. Multiple phases are 2 diets, A and B, and every 3 days they change it. A little bit more of B with less of A, more B, less than A. And they made 14 diets. When you see 14 diets, you see no changes in body weight, no changes in feed conversion, no changes in protein consumption, but better protein deposition. And one more thing, more fat deposition, telling us, or telling them, that they can squeeze a little bit more the diet, because something is happening in this metabolism, that some energy, amino acids, could be transforming back to fat and increasing the fat over here. So we have something to look on that diet either. And the most important thing is nitrogen excretion for males minus 25%, and for females minus 15%. That eventually shows that that diet was more for female than for male, in my sense. But the point is, if we want to look the perspective of less protein, less litter, less quality of the environment, we need to be looking those things. Another thing that bothers me a little bit as a professional for almost 50 years, many places in the world, we like to produce the chickens mixed, males and females. They were not made to be males and females together. Because if we look the average daily gain of a male to get to this amount of weight, around 92 grams, they get with 24 days. The females need 36 days. And never will make 110 grams, never. When we look at the body weight again of 3,200, the males can be killed with 41 days, and then females will need to stay for 45 days. Why I need to maintain the males for 4 more days just to make the average, all right? Another point that we talked about that before, when I have an average of 3,200 grams, I have hens with 2,500 grams and males with almost 4,000 grams. How I adjust the nipples? For the females or for the males? What about sustainability, animal welfare? And that is something that's very funny. This is a flock that the idea, that's a real situation in Brazil, that the owner of this company were looking at that time, because now we are talking in Brazil 3.2, 3.3, 2.5 kilos mixed fat, mixed sex. So we took animals from this flock and we measure individually hens and males. Look, the only thing that they didn't have was the amount that they were expecting. That was the weight of the females, and that was the weight of males. Why the males need to stay for 5 to 6 more days to push this weight that never will come? I leave this message to you guys. And more, the mixed sex, 11% variability. Males and females, around 5% variability. So when we are looking variability, when we are looking sustainability, when we are looking animal behavior in welfare, we need to look about mixed sex and separate sex. And I didn't talk about differences in the nutrient requirements that are different too. And to get to the end of my presentation, this is another thing that for me as nutritionist and a guy that looks on water, you know, and the subject of this conference is water, is the comparison what is happening with the slow-growth chicken. This is Ross 308, and thanks Alex, because a paper of Dr. Corzo and Dr. Avendano. Ross 308, 65 grams per day. This new line of slow-growth chicken, 34 grams per day, 52% less, 94% more days to get the same weight, 33% reduction in feed conversion, with the average adjusted for the same weight, that was 2.5 kilos. Water consumption, 33% more water consumption. Land to produce, we were talking about that, no? Land to produce the same amount of corn and soybean to produce the same amount of chicken, 33%. In broiler houses, we need to have 200,000 more, 200% more houses to produce the same amount of meat. For you that are not too much related to this, a chicken house today, very sophisticated as we are seeing, is around $400,000 to $500,000 per house to 35,000 chicken. How many $1 million will need to have these to get the same amount of meat to feed the world? So that's my question for you, for me to think about sustainability from now on. We know that sustainability is a mixture of social, environmental, and economic. We never can find the three together, but we need to match those as close as possible. And to finalize, I have 4 considerations that I believe to be important. Litter quality is a multifactorial condition where environment and water management are the ones that can affect the most. Don't try to save the world. For example, if you have hot water at the first week, you have wet litter already in the first week, because the birds drink more water, and was said that before by Corzo. They drink more hot water, and they spill more water. Because remember, they use 20%, and 80% what they drink, they need to throw out. So, management and chicken environment. One thing that is very important to say, that academic knowledge about the condition is immense. You go to the literature, well, in water less, I should consider what was said before by Corzo. But it's still there. But the translation of that knowledge to the real life is always not that simple as the people think. Get to the chicken house, get to the chicken farmer, talk to him and see how much he knows about physics and biology to treat a Ferrari with that complexity that the Ferrari is. It's important. You cannot transform someone that had a mindset to a very complex mindset. Nutrition can mitigate, for sure nutrition can mitigate and must mitigate, but don't think that we will fix a problem over there with a nutrition over here. And to minimize this condition, sorry about that, just with a strong extension and training. For me, as a final consideration, poultry production from now on is science and training. And not training at home, it's training inside of the chicken house. We need to bring our knowledge to the chicken owner and not just get it as a full information that's very important for us. So again, thank you very much to Odisseo to this invitation. It's an honor to be in this place, so beautiful, and with you listening to me. Thank you very much.